The northern giraffe, also known as Giraffa camelopardalis, is defined by its extremely long neck. This neck is used to reach leaves on tall trees. It is also used as a weapon, as the head of the giraffe acts as a club. This is a structural adaptation which has arisen from the pressure of taller trees. The Indian peacock, also known as Pavo cristatus, has a unique adaptation, being the feathers on its back. These vibrant feathers help the male peacock attract a mate, while also scaring predators with the feather's size and appearance, which looks like a bunch of eyes. This adaptation most likely arose due to breeding competition. The seal has many interesting adaptations that allow it to move on land and in water. Most noticeably, its front flippers, which bend on land and remain straight in water. The seal starts its life with fur to keep children warm from the cold conditions, but then loses it to move quickly in water. The meerkat, aka the Suricata suricata, is a very social animal, which lives in colonies. In the colony, one meerkat stands sentry at all times to warn others, which is done through various calls which each signify a different predator. This adaptation is most likely due to their small size and vulnerability. The African wild dog is similar to the meerkat, as they also live in packs. The wild dog also shows some sentry behaviour when guarding the young while the others hunt. This adaptation likely arose due to it being a hunting advantage. Pelican, also known as Pelecanus onocrotalis, has developed the behaviour of fluffing up its feathers in the cold, as seen here. This traps small amounts of air between the bird's feathers, which eventually warm up due to dispersing body heat. This adaptation has arose to allow the pelican to live in climates with very warm and also very cold seasons. The rhino iguana has cold blood similar to all reptiles. They must bask in the sun to raise body temperature and find shade to lower it. This is an advantage in hot, dry climates where the iguana can keep a constant warm body temperature without the need of food energy. The Asian elephant has large blood vessels in its ears which work as a cooling system. This physiological adaptation works with the behaviour as the elephant flaps its ears to cool down quickly. This adaptation likely arose from the selective pressure of hot climate in Asia, where elephants required a more efficient cooling method than sweating. The banded rock rattlesnake is venomous as it produces venom and uses it to kill prey. This physiological adaptation is linked with the structure of fangs, as venom is delivered to prey through fangs. This venom is produced in small sacs behind the eyes. This adaptation likely arose due to unsuccessful hunting with the use of only a bite. Convergent evolution is when two unrelated organisms evolve similarities when adapting to similar environments. Flight is a major example of convergent evolution on a large scale. Capacity for flight is found in insects such as butterflies, as well as mammals like birds and bats. All these species are extremely unrelated, but have developed the same adaptations due to a similar selective pressure, whereby airborne animals are harder to hunt than animals which remain on the ground at all times. It also has the added advantage of being able to maneuver swiftly and reach food in usually out of reach places. Here are 4 flight-capable animals who are not closely related: the butterfly of phylum Anthropoda, the bat of class Mammalia, and the pelican and lorikeet, who share the same class but different order. Divergent evolution is where the selective pressures on one species has resulted in the formation of a completely new species. The best example of this is with human evolution. This process began with members of the hominids, who were our first common ancestors around 5 to 8 million years ago. Over time, these ape-like creatures evolved into the modern-day Homo sapien due to selective pressures, where intelligence and use of tools gave a major advantage over all other animals.